So like what is the history within the Teradata? So history means some of the points is important. 4 or 5 points are very important. So about the history point of that red color I noted here, red color. So the 1992, actually 1979, the Teradata Corporation is founded in Los Angeles. So this is some historical things are there, but these are the no important things. You can read it, you can work on that. Okay. But so red color mark like given that red color. This is very important. So 1992, the Teradata is merged Ensure Corporation, Ensure, and 1991. Just observe here, Ensure Corporation is acquired by the AT&T. So what is the AT&T? This is one of the telephonic company, right? Telephonic.
Yeah.
AT&T.
It's phone company.
Right. Yeah. This is our telephonic company. Actually, this is the Ensure Corporation. Previously, the Ensure Corporation is acquired by the AT&T at 1991. But in 1992, the Teradata is merged into Ensure Corporation. So which year that Teradata is merged into Ensure Corporation? That is the 1992. This is year is important. From the interview question they are asking. That's the reason. And so.
Oh, really? Okay. I would not expect to tell the truth this question. Okay.
Yeah. So, and here 2002. As well you can say December 2002, the V2 Warfare version is released. The previous version, that's the old version. The V2 Warfare version is supporting the 296 node system production. Up to 296 node system production, it is released. After 2005, V2R6 is released, but this is a failed version. So that's why before that I said, right, V2R5, V12 version, V13 version. I'm not mentioning the V2R6 version. So V2R6 version is the failure version. That's the things. And here, Ensure and Teradata separated by the 2006. Yeah, Stanley, can you hear me? Hello? Hello, Stanley. Can you hear me?
Hello?
Yes, can you hear me?
Something.
Yeah, network.
Now yes. I lost you for a few minutes. Yeah.
Right. So here, 296 up to 296 node system production is supported V2R5 version, but V2R6 is released at 2005, but this is a failure version. And 2006, Ensure and Teradata Corporation is separated. Just observe here.
Okay.
1992, Teradata is merged Ensure Corporation. With help of the Ensure Corporation, V2R5 is released. It supports the up to 296 productions, load production.
Okay.
So, but the 2006 onwards, the Ensure and Teradata is separated. 2000 onwards. So, with the combination of Teradata and Ensure, V2R5 version is released, but while the Teradata Corporation V12 version is released, is supporting the 512 nodes production system. 512 nodes, up to 512 nodes is supported. So only the Teradata Corporation, 2006 is the release, this is separated. Ensure is a separate corporation, Teradata is a separate corporation. Okay? These are the separate corporations. But when the 2007 V2R5 is released, it supports the 512 nodes. And after 3 years, almost after 3 to 4 years, at the level of, say, October 20th, 2009, as well as the date, released the V13 version. So the V13 version supports the up to 1024 nodes. Up to 1024 nodes. And 2014.
Twice more.
Yes, that is quite. And here 2014 is released. To the year of the 2014, the week 14 version is released. The support.
This year.
Yes, this is the latest year. This year, maybe that is February or March. I am not sure the month, which month. I am not sure. So this year, recently the week 14 is released, but still the 14 version is not maintaining. It is going to the. It is not implementing. It's going to the. Progressing status. Some debug stages are there. They are debugging some of the things. Debug stages are there.
So they're probably testing it before installing.
Maybe for implementation take the 1 or 2 years maybe. Once your version is releasing, for implementation take the 1 to 3 years maybe. Just observe here, V2R5 is released 2002. After that, V2R6, V2R6 is supporting the 2005. How much are gap here? 2 or 3 years of the gap, right? One version to one version. And 2006 is separate, and 2007 to 2010. 3 years gap is there, right? 12 version to 13 version. 3 years gap. So after 2010, 2014, after 4 years, almost 4 years, the gap, your 14 version is released. Still, the 14 version is going not the implementation, but the debug stages are there. Debugging. Progress is going on. And that is about the history. These are the red color marks is important. Just observe that things. The remaining not important. I mark right the red color mark. This is very important. The points and all. So this is about the history. What is the Teradata history? Okay. And
Nagesh, quick question. When you say 2005 release failed, does it mean they're all back to previous version?
Yes. Once this version is a failure, still that the 2005 they are working the V2R5 version only.
So they're all back to previous one, right?
Right. V2R5 version. If V2R6 is a failure, then go back to V2R5. So whenever you are releasing V12 version, from 2007 onwards, V12 version is going to implementation. So these are some of the points of the history points. And Teradata futures. What are the futures? So this is the design. Design means not the design, something. Design means you can import, you can export. That is the design part. You can execute the scripting. You can import the data, you can export the data. So that is the design. I am telling about the not design means not the diagrammatical, you are not designing something. You are not designing. So design means you can progress processing the data. How much data you are progressing? Large quantity of data. Import and export with the help of the utilities. With the help of the utilities, you can import and export the data. That is the design progress is going on, and a large quantity of detailed data is going on. And the Teradata is the ideal tool for data warehouse applications. So you can say simply Teradata is the data warehouse database, right? So this is more compatible with the data warehouse applications. We support the terabytes of the data according to your client requirement. So this is the ideal tool that the data warehouse applications. And its parallelism makes easy access to very large table is possible. Very large tables. I mean, it's accessing easily. Why? Because of this support the parallelism. For example, you have the multiple tables are there within a source level. You can easily get into the data if you have the large amount of tables, multiple tables. That situation, you get the easily accessing, you get the easily answering, you get the data, select the data. So easy access to very large amount of tables if possible. Why? Because of our Teradata is supposed to make sense of the parallelism.
Okay.
And open architecture or open system. Open architecture or open system. What's the meaning of that things? Open system means it support any OS operating system, open system. And open architecture means it support the parallelism. See, industry standard components. Industry standard components means if any types of data is converting into your client format of the data, standard formats of the data, that's the BTED. Yesterday we were discussing about that, right? BTED.
Yeah, what is that?
BTED. What is the BTED? Basic Teradata transaction or transformation.
Yes. Okay, now I got it.
The industry standards is converting into your formats. See here. BTED application.
I remember.
Right.
Yeah, I remember. Yeah.
That point you are covered here. So, if any standards, industry standard component is maintained, is supporting, that's the reason. And performance is increased linearly. Why? Because of we can add the multiple nodes. For example, I'll give you some example. So we have one project. Within the one project, you are only one resource there. What happened? It takes some more time that your each and every one resource is going to work on that. Your button is happen, right? Button is happen. For example, you have the multiple people are there, my team is there. Each and every team are going to share the memory. Why? Because see here, linear components and nodes are added. Why? Because of, see here, MPP and SMP. SMP means you single node architecture. MPP means you have the multiple nodes. What is the difference between here? One node means each and every word depends on single node where data is progressing. If you have the multiple nodes, each and every data is sharing into the equal data. See here, just see the diagram. I have the 100 parts of the data. In case we have the four nodes are there, each and every node is sharing the equal data. Yes or no? Right? 100 records means 25, 25, 25, 25. Equal data is sharing. Same thing your project. For example, get into one project. Within your project duration is 1 year. Within 1 year, we are going to complete. Within your project, only one employee there. What happened? It takes 1 year duration for completion of your project. Instead of the one employee within the project, you are added the 4 or 5 members. Just assume that 4 members is added, so some team is there. So your work is sharing into the 4 members, yes or no, team members. Within the 3 months, your work is going to complete your project, yes or no, standard, right? So your work is sharing. That's the reason your performance increase while you are added the multiple nodes. Instead of the one node, you can add the multiple nodes. That's the multiple nodes means depends on the nodes, depends on the version. You can support the multiple nodes. V2R5, V2R5 up to 296. V12 version, 512 nodes. V13 version, 1024 nodes. Depends on your requirements. Right.
And the number of nodes, Nagesh, number of nodes per version, is this per system or per what? Per MPP or, you know?
No. Actually here, within the real time, the MPP system is going on. MPP means the multiple nodes is going to configure it. For example, just see the example here. So here, my source data is the 100 terabytes of the data. 100 terabytes of data. So I want to maintain the 100 terabytes of the data. They require the 228 nodes. They require 228 nodes. So which version is supporting? V2R5 version, right? Up to 296, you can use the V2R5 version, right? For example, SBC, see here, I want to maintain the 150 terabytes of the data. So if you want to maintain the 150 terabytes of data, you require the 298 nodes. Just assume that one. 298 means you should be go for V12 version. Yes or no? What I'm saying here, your source data is increasing. Your nodes are increased. Yes or no?
Right.
Right. That is the reason I'm telling here. When added the number of the nodes depends on your source data, your requirements. Increase your database, increase your source data. You are changing your version. You add the multiple nodes.
Right. But that number of per version, let's say 924 nodes, right?
Right.
Is this per database or per database? And on your system, you may have multiple databases, right?
Right. Yes. Each and every multiple databases you are connecting with your server. Your server is maintaining multiple nodes.
Oh, so this is per server?
Right. Your server is maintained. Yes.
Okay.
See the diagram here. Your server, your Teradata server is maintaining multiple nodes, but you are connecting into with help of the multiple clients. Yes or no? See my diagram. You have the multiple database, like the multiple clients. You are connecting into your Teradata database server. So the server is maintaining multiple nodes.
Okay, and you may have one server or multiple Teradata database server, or just one?
Yes, one server is maintained. One server.
Okay.
That is the Teradata server.
Okay.
But the server is connecting into multiple users, multiple databases.
Got it.
So this is the added. So whenever you add the number of the nodes, your performance is going to increase, obviously. And runs database server to client application. Server to client. What is the difference between here? Database server to your client application. So each and every client data you can import to your Teradata database, and from your Teradata database to your send to your export to the client with help of utilities. So some interface is there, right? Your server to your client. You should be client and the server. Client means your client application. I am not the client means your client applications, not the client. So your database is there. So your database is connecting into your client server, server application. And your Teradata is runs under the multiple hardware platforms. Why it is hardware? So PDE is there. I explained right yesterday. PDE, parallel
database extension. Yes.
Whenever you go to start the server, the PDE is going to start. Once our service is started, you can log in into your database. Otherwise, you cannot log into your database. So the PDE, that is the parallel architecture, simply you can say, parallel data extension, parallelism is supported. So the PDE is run under your multiple hardware platform. Yes or no? While you are connecting to the server, you are connecting into your system hardware platforms, network platform. Without network platform, you cannot connect into your server. Yes or no, right? You should be connecting into your servers, different types of servers. You should be. Otherwise, you cannot work on that.
Okay.
So this is a multiple hardware platform. So these are all some Teradata features are there. That's the reason all the clients is connecting into or migrating into the Teradata. That's the reason all the clients is go for Teradata. And one more important point, this is the interview questions. What is the difference between our Teradata to other databases? Other databases means Oracle, DB2, SQL Server. These are all the multiple databases are there within the market. That is the other databases compared to our Teradata. So first point, process stores. Process store means how much storage capability is there. Capability. There are the trillions of the rows, terabytes of the data. Within the Teradata is supported, but other databases, millions of records, only millions. It supports up to 100 GB. You are not giving any constant value. This is approximate of the data. 50 to 100 GB space is supported other databases.
Right. I remember when we used DB2, we had millions rows of tables, like transaction table.
Right.
And we were thinking about performance tuning and stuff like that.
Right. But the Teradata is supporting trillions of the rows. And here, second point, parallelism. That's the unconditional parallelism. Unconditional means from the starting onward, your Teradata is going to work on the parallelism. The PDE is started. PDE means the parallelism, unconditional parallelism. But other databases,
like by default, right? PDE is like by default.
Right. Multiple nodes are going to connect it. That's multiple unconditional. And here some conditions are there. Yeah, I'm not sure they here unconditional. That the conditionally your data is going to parallelism, other databases. And one more important point, that the architecture. So Teradata is the shared nothing architecture that is called as the parallelism. But here other database shared everything. Shared everything means, for example, I have the 10 records of the data. Within the Oracle database, how your data is loading? Sequential manner. Sequentially. One record after that, one record. Record by record, your data is going to loading within other databases. But our Teradata, all the records at a time parallelly is loading into the target. You are not sharing record by record within the Teradata. Parallelly, all the records is loading. That's the reason your architecture is called as the shared nothing architecture. But other databases sharing one record by record. Once one record is loaded, then second record is going to loading. So record by record, sequential manner, your data is loading into the target. That is called as the shared everything architecture. And fourth point, very important, loading and scriptings. So load utilities, you can say utilities. Within the other databases, only one utility is there, that the SQL loader or DB2 loader. DB2 loader also there. DB2 loader. This is the one utility within the Oracle. DB2 loader for DB2 database. So other databases, we have the one utility there for loading. But our Teradata, you have the 5 utilities are there. Different utility, you can use the different situations. For import, one utility, for export, another utility. As per your requirement, you can use the different situation. While using your utilities, you can import, export. But while import, export, your data is the storing type is the randomly, even automatically your data distribution happen. That the primary index file that has algorithm. Automatic partition, not the manual range partition. Yesterday I shown, right? Data distribution.
Yeah.
Other databases, Oracle, manual range partition, but our Teradata, automatic partitioning is going on. But
can you add automatic partitioning after automatic? Could you please?
Pardon? Yeah.
Could you write after automatic partition? Space partition. Yeah.
Automatic partition, like this.
Yeah. Thank you. Mm-hmm.
Automatic partitions is happened within our Teradata. Mm-hmm. But here, your data is loading by the sequential manner, not the automatic. Right. That's the manual range partitioning. It happened.
Mm-hmm. Right. What about GML, like inserts?
GML?
Data manipulation language, DML, insert statement.
Right. DML, the DML, data manipulation language, so you can update in parallel, automatically the updation happen. So with help of the utility, you can insert as well as you can update. So first of all, upsert, you call that the upsert. Upsert means update, then insert. Upsert will going to work on that. I will tell you the topic will come while utilities. I want to show you that also. Mm-hmm. Upsert will happen.
Okay.
Yeah. 1 second. Upsert. Yeah. See here. Update, insert, delete. That is called as the upsert. Multiple.
Where is this word?
Yeah. Upsert. Somewhere there. Upsert.
Okay, we will get to it later. It's okay, that one.
Insert, then update, I want to show you, insert, delete, update, something there. See, for example, here, you can say, at a time you can insert the data, and you can update the data. See here. Mm-hmm. Insert, update means, first, already you have some data in there. In fact, if you have the data, first of all, update the data, then you can insert it. Update, then insert. That is called as the upsert.
Okay.
So the topic will come here, utilities, that's the multi-load. That is upsert. Yeah. Please go ahead. You got it the phone.
I'll call him back. This is, I don't know. Thank you.
And here, this is upsert is going on. See here, that word, upsert. Insert, update, delete, and upsert.
Upsert, okay.
Upsert. The topic will come, I will explain that when this.
Alright, okay.
And so this is very important here, the differentiation between our Teradata to other databases. These are the 5 points. 5 points is very important. Mm-hmm. So once again I can explain briefly. It supports the clearance of the rows, unconditionally, share nothing architecture, different situation you can use it, different utilities. Your data is loading into the randomly automatic partitions happen within our Teradata.
And evenly distributed, right? Even means evenly distributed.
Even means equal data. Randomly, equally, your data is distributed. For example,
what is even stands?
Even means the equal data. For example, see here, I have 100 records. The 100 records is sharing equally. Right? 25, 25, 25.
I got it.
That's it.
I got it. So it's the same what I say, equally distributed, right?
Right. Equally. That's called the even. Yeah. Equal data distribution. That is randomly. Random is maybe, for example, I will show you one example here, diagrammatically. 1 second. And here, see, I have some disks are there here. Just fallback or primary rows are there, right? Disk level. So you have the 4 disks are there here. I have the 4 records. 1, 2, 3, 5, 6, 8, 11, 12. So like 8 records are there, my source data. So how your data is distributed here? Randomly, your data is loading into all the 4 disks equally, right? You have the 8 records, 2, 2, 2, 2. That's the 8 records. But you have the one record loading into the fourth disk, second record goes to the first disk. That is called as the randomly, yes or no, random storage.
Okay. Got it.
Randomly, equally, right? That is the point. And
randomly means
not
sequentially.
Yes. That is the Teradata. And automatically, I'm not giving any path here. Automatically, your data is distributing in your disk level. That is called the equally even data distribution, and auto partition is happened within our Teradata.
Okay.
These are the different, very important. This is one of the introductions.
Got it.
Right. And after that, Teradata implementation. So what kind of clients you are implementing our Teradata? So within our world market, retail markets, largest bank sectors, global telecommunication, AT&T, telecommunications, and airlines, insurance companies, and largest pharmacy companies, the worldwide, top 10 of the worldwide. The companies almost, they have working the Teradata. I given you some of the list here. Retail market, Kmart, Walmart, these are the retail market clients. Yes, Stanley, right?
Yeah.
And transportation, American Airlines or Air France. So some of the transportations. Insurance companies, Hartford, Mercy Health, these are the insurance companies. Government agencies like ARS, DOJ. So I think you know about these all the clients better than me. Air Force weather. And telecommunication, AT&T, this is the worldwide biggest telephonic companies, telecommunication.
So this is the list of big companies which fall into different categories.
Yes, list of the clients. Some are very young. This is one of the clients. Financial, Bank of America, Barclays, these are the clients. So these are all the clients. Currently, they are using the Teradata database.
Okay. Oh, so okay, I see. Okay, so
Yeah, these are the clients.
So this is. So you're giving me the list.
List of the clients. List of the clients.
But it's not full list, right?
Pardon?
It's not a full list. It's not a full list. It's not all the companies.
Yes. Not the full list. This is only some of the client list. Within the world market, we have multiple clients are there. Some of the main important clients, major clients, I given the listed here. I listed here.
Right.
Some of the clients listed here.
Right.
And one more important point before that I explain. If your source data is increased, your versions is going to increase. See here, you have the 100 terabytes, it's maintain the V2R5 version. Version. If you increase your source data 150 terabytes of the data, they can use the 12 version.
Just 1 second. I have a question. I need to confuse Nagesh.
Yes.
You see, the thing is, if you have a database, right, for a specific company, and you have, let's say, 100 terabytes, like you have an example. You on your system. Okay, on your system, you have the version 13. So why should you go back to? I mean, it's just about the number of nodes, right? Or is it fixed number of nodes?
Yeah, that fixes the number of the nodes, but version by version. So V2R5 version only 296 nodes only. I want to maintain the 298. I require the 298 nodes, but I can't use the V2R5. You can go for V12 version. That's the better way.
Yeah. But on your system, if today, let's say, your company has a version 13 installed, it means 124 nodes, right? So, and you have a database which is under 100 terabytes, you still will use version 13, right?
No. I am using the V13 version my source data it's increased. That is 1,000 terabytes of the data. 1,000 terabytes of data I am using. I want to maintain the 1,000 terabytes of the data. I can increase the number of the nodes. If you increase the number of the nodes, you can increase your versions. So I given this is the approximate of your source data. This is not the exact figure. This is approximate of your terabytes of the data.
Okay. Right, but today you will not go to older version, right? Today, if you install version 13, you will continue to use version 13. Because here in your example, it's just you pointing. You're representing Walmart, right, as a client.
Right.
You're basically giving it as an example. But the version, I think you're kind of referencing what used to be. But today, if you have version 13, you're not going to go to version 2. Release 5 or something like that.
Right. But here, depends on your increase the source data. For example, Walmart, maybe it maintain the 1 terabyte. Maybe.
Right.
Maybe it maintain the 1 terabytes of data. The Walmart should be maintain the V12 version. Right? You are migrating the V2 R5 to V12 version. They should be maintained. They can migrate. That's all. Version migration. It's happened.
Okay.
So V2 R5 to V12 version or V12 version to V13 version. So based on your increase, that's what I try to explain here. So increase your storage space. Increase the storage space. You can maintain your version and also your number of the nodes.
So you're increasing number of the nodes, right?
Right.
Bigger database, then more nodes you need.
Yes.
For better performance. Okay.
Right. So increase your source. While you are increasing your source data, you can maintain your number of the nodes and you can increase your versions also. That's what I try to explain here. So these are the points up to here. That is the basic knowledge about that. That's the Teradata.
Okay.
So up to here, any doubts, please? Teradata implementation, what is the difference between Teradata other database, what is the Teradata futures, what is the airstrike, and what is the advantages, what is the Teradata, why go for Teradata. These are all the important points. That is the basic. You should know the basic knowledge about the Teradata.
Okay. Okay.
First part, come to the Teradata architecture.
Right.
So, can you go for tomorrow, the Teradata architecture? This is important. We can go for a fresh mind.
Oh, you mean tomorrow?
Tomorrow. This is the important topics, right? Very important. That is the architecture.
Okay. I was looking into it a little bit,
Right, little. So I can explain briefly. I can explain here. Node architecture. Architecture means this is a node. You can maintain the version to version, you have number of the nodes, right? Within the node, what happened? You have some points are there here. What is the channel? What is channel at a system? For example, you get the data from the client. You are connecting into your database. Yes or no? How you are connecting that client? With the channels. You are connecting your client. This is the network.
Is it a physical connection?
This is physically, internally, the connectivity is going on.
Okay.
That is channels.
This is
network channels.
Okay. This is network channel with mainframe, I guess.
Right. And mainframe is here different operating system they can maintain. So channel drivers, Teradata gateway. So for example, you get it from the client. So you are connecting to the channel driver, your data storage initially. Once you get the client data, I'm not loading your database directly. I'm connecting with your client and get it from the client, the data. Initially I stored in some buffer space. Buffer space. That is the channel driver. That is one of the driver connectivity. For example, I want to go for reference data, already existing data. I'm connecting a local server. You have the internal server there, right? You have the different, two servers are there. Your local server and your client server. Both the things are there. For reference purpose, you are connecting into your local server. That's the LAN connectivity. That's the Teradata gateway. So, channel or LAN, these are some network areas. You are connecting into your client. Once you get the client data from the channel attached system, is loading into the channel driver or Teradata gateways. Once you get the data into the from your client, you're loading into your buffer allocation. Whenever you start a Teradata service control, the PDE, 1 second, Stanley, I got it. Yeah.
Okay.
No problem. Yeah, please cut it. Yeah. So here the PDE is there. What the PDE means? When
parallel database extension.
Yes. 1 second, please. 1 second, please. Hello? Yeah. Please. Hello? Yeah, please. Yeah, tell me. Yeah. అదే నేను సెక్షన్లో ఉన్నాను అందుకే నేను సెక్షన్లో ఉన్నాను కట్ చేసుకున్నా నో ప్రాబ్లం చెప్పండి రేపు కుదరదు సార్ యాక్చువల్గా ఇప్పుడు హాస్పిటల్లో ఉండి వర్క్ చేస్తున్నాను నేను లేదు అంటే మా అబ్బాయికి సర్జరీ ఒకటి ఉండే అందుకని హాస్పిటల్కి మార్నింగ్ అడ్మిట్ అయ్యాము సాటర్డేకి వచ్చేస్తాను సాటర్డే డిశ్చార్జ్ అవుతాడు రేపు మార్నింగ్ 7:30 హాస్పిటల్ నుంచి వర్క్ చేస్తున్నాను ఎందుకు క్లాస్ వేస్ట్ అయిపోయింది కానీ వర్క్ చేస్తున్నాను ల్యాప్టాప్ అంటే మార్నింగ్ మిమ్మల్ని కాల్ చేస్తాను ఒక 15 minutes సెక్షన్ అయిపోతుంది మిమ్మల్ని కాల్ చేస్తాను సో హియర్ యువర్ ఆర్ట్ ద PDE is stated there. Stanley.
I'm listening here. No problem.
So here PDE is there. When you start the service control, the PDE is going to start. PDE means that when you start your Teradata service control, you're connecting in your server parallelly. Once you get it parallelly, you are logged into your database. Within your database, the 4 applications is going to work on that. PE, that's the partial engine. Binet, this is one of the driver. Connectivity. YAML, access module processor. Virtual disk, this is the disk level. So I can explain you in depth, these are the points level. I can explain. So you are going to connect multiple OS database, OS level, Unix or Windows or any OS. That's the open system, right? Our Teradata.
Nagesh, let me ask you. Unix and Linux, is it the same or is it different?
That is the same.
Linux and
Unix or Linux, both are the same. There are no difference.
Okay, I got it. So this is operating system. Is it
Windows or Unix or mainframe also one of the OS is maintained. Mainframe or Windows 7 or Windows or 2000 Windows XP. These are the OS. Unix and Linux, these are the OS level. So you can maintain any OS, that Teradata, that is called as the open system. Open system. So once your OS is started, you start your Teradata database. That's the PDE. Then only once our database is started, we're connecting into these 4 applications, 4 activities. PE, Binet, YAML, virtual disk. We have some different works are there. Within the PE sub-work is there. I can explain you the coming topic here. Under the PE, what happened? Session control, parser, optimizer, dispatch will happen. PE architecture, the individual architecture. PE architecture, Binet architecture, YAML, virtual disk architecture. Individual architectures are there. So the coming topic I can explain. These are the individual, what happened internally. So here I am showing only box level, PE, that's all. But within the PE some work is going on, right? Standard.
Of course, yes. Of course,
So
yes.
what type of work is going on, I can explain later on, by tomorrow.
Okay.
So one by one, within the PE what happened? What is the binary? What is the YAM? Within the YAM, what type of work is going on? How your data is loading in the virtual disk level, disk data. Right? These are all the things I can explain by tomorrow. Okay. This is the important topic. That's the reason with a fresh mind you can work on that. That's the reason.
Okay.
Yeah. So
Bless you.
yeah, this is the node architecture. And one more important point, MPP and SMP. What is the difference between them? You can use it within the Teradata MPP system. You cannot use the SMP, right? You can use the MPP system only. Our Teradata, multiple nodes. Multiple node configuration.
But why cannot you use SMPs? It's
SMP
also
means only
multiple.
single node architecture.
Ah, I see. Single node architecture.
Single
Okay.
node. It is not meant in the sequential manner. That's SMP meant in sequential manner.
I see.
That's the reason. So I explain by tomorrow. At the same time, you can meet on. These are the points I can explain tomorrow. What is the Teradata architecture, node architecture? What is the SMP, MPP differentiation? So what are the Teradata components? I mean, within the PG, what happened? And what the binary? What is the YAM architecture? So I can explain by tomorrow at the same time. Yeah, please, yeah, study.
Yeah, I talked to you yesterday, Nagesh, about the documentation so I can read, because yesterday I could not get the recording from yesterday's topic. I could not review anything, and I did not have any documentation. And you told me you probably will send it to me today.
Right. I will send you. Yeah, I will forward to your organizer. Your organizer will forward to you. Okay.
But when? Yeah, when?
Within the 10 minutes, I will forward to your organizer. Within the 10 minutes.
Oh, you will forward to me? Okay.
Yeah.
You do know my email address, right?
No. I don't know about your email ID, but I will forward your organizer. Your organizer will forward to you within the 10 minutes. Okay.
You mean documentation, right?
Right. This documentation, this knows.
Okay.
Forward. Okay. I will forward your organizer. Okay, Stanley. Your organizer will.
Okay.
You are sent to you.
Because I'm expecting to get the documentation so I can after class I can read and prepare for next one.
Within the 10 minutes, I will forward your organizer.
Okay, thank you, Nagesh. Thank you. Okay.
Within the 10 minutes. Okay.
All right.
So we can meet on by